Welcome to another video for the Modbus TCP server and RTU client functionality. So even though it says TCP server here, what we're showing in this video is equally applicable to Modbus RTU client. So today we're going to look at the exceptions and the errors that a Modbus TCP server can generate. That's important because if you're writing software for a slave, you want to know how the slave will respond when a TCP server error occurs or an RTU slave error occurs. So for that purpose, even though naturally our server here wouldn't actually send an error back because it's got all the information available, we can simulate some of the errors. So the first option that we've got here is we've got a mute functionality. Now the mute functionality allows us to mute the server. So that means the server, whilst it is there and it is operating, it is just not responding at all. So if we use a client here, and we do a request, and we can see at the moment it's responding fine. But when we mute the server and we do a request, there's obviously a timeout that occurs, and it's waiting for a reply, but it's not getting a reply. So it says there's no response from the other end. Now we can actually look at the data log window as well and see what's going on here. We might just put that down here, so we can see what's going on. So we make a request. A request is received. And there's the retry. So this is obviously set to do 3 retries. So it's retried 3 times, but then finally gave up and said there's no response from the other end. Okay, right. That's the mute function that's available. So we can just mute at any point in time. But then we can simulate errors, and some of the errors that we can receive. There's 3 sections in here. One is to actually simulate an error reply. And let's just have a quick look at that. If we simulate an error reply, we can, for example, we can say let's have an illegal function. So if we send a request from our slave, there is an illegal function that comes back. However, we've got this set to 1 in 5 rather than 1 in 1. So we've got to set it to 1 in 1 so that it does it every time. So let's do that again. And here we go, the reply, and we can see that clearly. There's the request that has come through, and the reply is an error reply. You can see that with the highest bit set in here, and the error that we're sending back is 01, which the client is correctly interpreting as an illegal function. So we can select what type of error we want. We can have it a device failure here. So we send that across, and the response back is error on function 304, server device failure. So therefore we can check that. We've also got the ability to do a random exception. So that means we're no longer going to have the exception that we have set. It's going to be one out of the exceptions available. So at the moment here it's picked exception 1, which is illegal function. We do another one, it says illegal data value. So we can have a random exception as well. And the other option that we have, if we don't want every response to be an error response, we can set it up to, let's say, half the errors are going to be response errors. So then when we send the reply, that one here, for example, went through with success. That one is okay. That one here responded with a device failure error, like we've got set here. Now the number that you see here, it's actually a random number, but it will be a number which says a good one, there's another good one, there's another good one, there's a failure, there's another failure, there's another failure. So when you select 1 and 2, it doesn't mean that every second one is a failure, but random over time, every second one. So if you do 100, there'll be 50 failures in there. So you can put that exception rate in there as to what you want. So that's our Modbus exception that we can set up. So let's get rid of that. We've also got the ability to do a response delay. So we can have a response delay, and let's say we're going to delay our response by 500 milliseconds, because normally the server will reply immediately, but when we put a response delay in, you can find out how your client is handling a delay. So here we go, and you can see here it's around about 500 milliseconds. So there's some timer tolerances within macOS. But you can see that we have waited about 500 milliseconds, a little bit longer, to send that reply. So you can set that reply in here, or you can set it to a random time, and you can select the minimum and the maximum. So it'll have a random response delay. This is very good if you want to simulate network congestions or things like that. So every time it responds now, there'll be a delay which is somewhere between 500 and 1,000 milliseconds. So you can see here, there's various delays that are now occurring. So that's the random response delay. So that's good for testing how your slave is, or your client is responding to a delayed response from the server. Very important function. And then we've also got something which is a force retry. Now, force retry means that we are forcing the client to go and retry. So the first time the client sends something, we won't respond to it. We'll make it retry, and we'll see if the retry function is working. So let's just send a request from our client, and you can see the first request come in, but no response. The server didn't respond to it. The second request come in, and the server did respond to it. And the client is happy with that. So it says, yep, that's a success, because the client is obviously set up to allow a number of retries. So that's how you can test out the retry functionality. Here's also a random. So you can simulate a congestion where you can have a number of retries between your minimum and your maximum number, and it'll just randomly select that. We've also got something here which is called a Retry Timeout, and that is required because the server has to remember each of the retries, and it doesn't want to get the retries mixed up. So let's say, for example, that the client fails to respond at all. The server is forcing a retry, but there's then no further response from the client. The server would then be waiting forever if you've got this set to one retry. In order to make the server time out, we've got and normally set a reasonably long time in here. 5 or 10 seconds is good. Which means after that it'll no longer wait for a retry. If another request comes in, it'll start a new sequence where it goes, okay, we're now looking for 2 retries before we send a good response. The other thing that is worth pointing out is when any of these are enabled, because you may have that window closed, that text here, exceptions, is actually red. That means that you have one of them enabled. It doesn't tell you which one, but you have one of them enabled. So while that is red, don't expect the server to have a good reply all the time. So you can select one or more, but as soon as they're all deselected, that goes back to grey. In order to get that exception configuration window up, you can either click on the disclosure triangle, or you can click on the text here. Either of that will bring up the exception configuration. So that will allow you to do some testing of your client, or maybe for the RTU version, for your RTU master to see how it responds to those various server possibilities, server issues that could occur. All right, I think that's about all I can tell you about Modbus exceptions with the TCP server or RTU slave. Thank you for watching this video.